Okay, here we go. Yesterday was the basis for what we really want to do. And this is just going to take a couple minutes, and then you guys are going to have a little bit of time working on an assignment, and we got to move to the next thing. We're going to talk about domain, and we're going to talk about composition. Those are our two topics today. You've already learned about domain once. Here it goes again. I don't know what that function looks like. Do you? No. We haven't seen one like that before, have we? I know what a square root guy looks like. That looks something like that. I know what a line looks like. But I don't know what that thing looks like. But based off what we did yesterday, we said, oh, I understand that two functions can be added together. That could be function A and that could be function G. And you learned that if you wanted to determine the domain of those functions, what you did is you found the domain of F and you found the domain of G and you looked at the overlap, right? So let's look at the domain of F. How do you find the domain of F? We subtract that 2 over, we get negative x is greater or equal to negative 2. And we divide by negative 1 to get x is less than or equal to 2. So it turns out this domain is from negative infinity to positive 2. Easy peasy. The next one, x plus 1, what's the domain of that? Why is it all real numbers, Evie? It's just a polynomial. Domain of that is all real numbers. What's the overlap between all real numbers and negative infinity to 2? Negative infinity to 2. That's my domain for that whole piece. So I don't necessarily know what that looks like, but I can tell you what the domain is at least. That tells me something interesting about the graph. Look at the next one. I don't know what that looks like, but I do know that it's F times G. What is the domain of x cubed? All real numbers. What is the domain of G? All real numbers. What is the overlap between all real numbers and all real numbers? So the domain is all real numbers. You can write that as all real numbers or negative infinity to infinity. Letter C, we've got division. Look at the top. What's the domain of the cubed root of x plus 1? And then I have the bottom. What's the domain of x squared minus 9? It is also all real numbers. But we say then that you can't divide by 0. So what are the two numbers that would produce 0 in the denominator? Yeah, so notice how the two domains are all real numbers and all real numbers, but you have to exclude the two that would give you 0 in the denominator. So x cannot be negative 3 and positive 3. That's where Evie was going. We're going to do through letter F here. Then we're going to have you spend about 4 minutes working on that next part of the assignment before we move on to composition. Here I'm subtracting two functions. I look at F minus G. What's the domain of F? Is that the same thing for the fourth root? We have to take 2x minus 7. Set it greater than or equal to 0. We add that 7 to get 2x is greater than or equal to 7. And we divide by 2 to get x is greater than or equal to 7 halves. Obviously, the overlap between these two is going to be from 7 halves to infinity. For letter E, the domain of the top is all real numbers, and the domain of the bottom is all real numbers. But as we said before, you can't divide by 0. What number would give you 0 in the denominator? Ooh. It would just be negative 1. If you set x cubed plus 1 is equal to 0, notice how you could subtract 1. And then when you cube root both sides, the cubed root of negative 1 is negative 1. So therefore, x cannot be negative 1. That's your domain. And for our last one, you have a polynomial, which is all real numbers. And then you have this one right here. So we look at that domain. We're going to say 3 minus x must be greater or equal to 0. Negative x is greater or equal to negative 3. X is less than or equal to positive 3. So our domain is from negative infinity to 3. Okay, so turn in your homework. That next piece, Ben's not here today to tell us he's behind in his homework. Okay, that next page, you got 6 problems. A and B happen to be the same, so you don't have to worry about A and B, okay? You just do one of them. But A, B, C, D, E, F, okay, those are what you guys want to spend about 4 minutes working on right now. Try to get a couple of them done. Answers are posted online. Answers are also up in front of class. Go ahead, take a little bit of time. Then we move on to composition, composition, composition.
Doesn't be the same thing. Why'd you get all really good? You can't have somewhere road and negative, so it's gotta be bigger than 0 then. Right, that's look, this is all numbers. Oh, but that's different thing.
We have a question? Hannah, do your goats have shelter for when it rains? Yeah. Right now, they'd be getting wet. Cross country runners started running first race at 2:30. So they are getting dumped on right now.
You think Isaiah's going to take it down?
I think he's got an excellent shot to go to state.
That'd be cool. Hey, what's the difference between these two?
They're not the same problem, so just do one of them.
Oh. Oh, yeah. Okay. Sorry.
He's very focused on the mathematics. There you go.
You won.
Sure is quiet without Brecken here today. Although Tyler is much worse behaved without Brecken to watch over. Okay, take another 1.5 minutes. We're going to move on to composition. Time is of the essence in our course. Don't have enough days.
Wait, what? Oh, you come to the negative. It's safe to your body because you're adding. Oh.
Looks like it's going to clear up right after this, so should be good. Okay, here we go. Turn to 2.8, 2.8, 2.8, composition of functions. This is the next spot you want to be at, composition of functions. Today I teach you something new, but it is not challenging. It is new, but it is not challenging. You won't know how to do it unless you see it, okay? So I taught you before that there's operations like addition, subtraction, multiplication, division. Give me another operation. Okay, square root, power, stuff like that, right? So today we teach you a new operation. It is called composition. It is a circle that looks like this thing right here. Composition. Composition is not for all real numbers. Composition is for functions, okay? So it does not work there. It works for functions, okay? We do not use it for numbers. We use it for functions. That's your group that you're working with. So f of g of x, that's the composition sign right there. Right away, you're going to think of it as multiplication, or you're going to think of it as, something like that. That's not what it is. It's not multiplication. It does not mean multiply. Here's what it means. It means you take f of g of x. Okay, so what that means is you have two different functions. You have g and you have f. You go ahead and take x and you drop it in for g. You then get an output, and the output is g of x. What do you think you do with that output? You then plug it in for f, and you get f of g of x. Okay? So, look at some basic examples. We're not going to do all these for sake of time, but f of g of 0. That's the same thing as f of g of 0. These mean the same thing. You could see either one expressed on the ACT, either one expressed in this class. And what it's asking us to do in this scenario is to take 0 and plug it in for g. So when I take 0 and plug it in for g, what's the output? I get 0. So it becomes then f of 0 because 0 was that output. I then take 0 and plug it in for f, and I get -3. The next one, I just switch the order. We'll see if it's the same. I start by taking 0, and what do I plug it in? I plug it in for f. When I plug 0 in for f, I get -3. So this becomes g of -3. -3 squared is 9, and then 9 minus 6 is 3. That's my output. Not complicated, right? Okay, we'll try a couple more examples together. If you see it written like this, that just means, again, that you take the -2 and you plug it into g first. If I plug in -2, I get -2 squared is 4, minus 4 is 0. So this expression here becomes f of 0. Now we'll determine f of 0 by plugging 0 in here, and we already see we get -3. What I would like you to do is I'd like you to do D, E, and F on your own. Try D, E, and F on your own. Go ahead. Slowly write the answers down up here so you can check them. Okay? Any questions on those three that I asked you to do? Anyone that you need to be seen further? Okay, so we're going to skip problems H and I. Skip problems H and I. I want to look at G and J. What is different about letter G and J? Instead of a number, I have just X, right? That's all I've got. And so what you do here is F is equal to 2x minus 3, whereas G is equal to x squared plus 2x. Okay? So this is asking f of g of x. So I take all of g, I take that entire piece, and place it in for x right there. And so I get 2 times x squared plus 2x, and then I have a minus 3 on the end. So I replace this x with that entire function. On the test, I'll ask you to write it without parentheses. We get 2x squared, we get 4x, we get minus 3. We're going to do letter J. Notice I have g of x. So I have x squared plus 2x, and I have x squared plus 2x. Those are the two functions I'm working with. They happen to be the same. This is g of g, so I grab this, and do you think I place it in for the first x, or for the second x, or for both? Definitely put them in for both. That becomes a little bit kind of lengthened here, as we have x squared plus 2x. It says we're going to square that, plus 2 times x squared plus 2x. I got to square x squared plus 2x, so I got to take that times itself. What do you get if you take x squared plus 2x and multiply it by itself? X to the 4th plus 4x cubed plus 4x squared. So we take the x squared plus the 2x. Notice that you have to multiply it by itself. As you FOIL that out, you're going to get 4x cubed in the middle. Then you get your plus 2x squared and your plus 2x. I can combine some terms together. X to the 4th plus 4x cubed plus 6x squared plus 2x. That's my resulting polynomial.
Wouldn't it be plus 4x?
4x plus 2 times 2x.
I'm sure you're right. I can't see it. Which one am I looking at?
For the second.
Oh, sorry. Yep. 2 times. There it is. Yep. So I got 4x. Yep. Thank you. Okay. Good job. Flip it over to the other side. Okay. Now we got to talk about what to do if we see it graphically. These are not difficult. They're just slightly different. Here it says we want to take f plus g of 2. If you look at the graph, the way that we do that is we do f of 2 and we add it to g of 2. Do you remember how I graphically find out what f of 2 is? I locate 2 and then what do? What do I look for? I look for the height of the function. I look for where f is at. So you can see that the height of function there is negative 2. And then I go to g of 2. So I locate 2 and I find where g is at. And that would be a positive 2. And I get 0 from that. The next one is subtraction and involves 0. I have g of 0 minus f of 0. I locate 0. What is the height of f, or g, excuse me? 2 minus 0. And I get 2 out of that. You try f times g of negative 1 and f divided by g of 0. You try those two on your own. I got 1 and 0. Everybody else good? Okay, our last two that we do for this, then we'll do our domain problems. We'll be done for the day. I got f of g of 1. We're going to look at this graphically. F of g of 1 is like f of g of 1. Okay, so watch what happens here. I plug in 1, and I look for the output of f. And the output of f is negative 1. I'm sorry. I don't plug into f, I plug into g. Sorry about that. I locate 1, I plug it into g, and I get 3. So this becomes f of 3. So now, instead of going to 1, I have to move over to 3. As I move over to 3, the height is negative 1. You try this one on your own, g of f of negative 2. You got 2? Did you learn something new today? Is it extraordinarily difficult? No. Could you picture seeing a problem like that on the ACT? Is that a problem you should now get? Oh yeah. And before, people would be like, I don't know that yet, so I can't do it. Okay? So, last 2 examples. It says to determine f of g and to identify their domain. Find the composition of the following functions and identify their domain. So we want to compose f of g. So this is not challenging. We've just seen it before. We're going to take what g is, and we're going to dump it in for f, right there. And we get 2 over 3 minus x. And what would you say is the domain of that function? X cannot be 3. Simple as that. Okay. The last one, we're going to compose g of f. Notice how we have f, and now we're going to dump it in for g. And that becomes the square root of 2x minus 6 minus 2. You can combine those terms together, so we have the square root of 2x minus 8. What do we have to do to find that domain? set it greater than or equal to 0. As we solve, 2x is greater than or equal to 4. So x is greater than or equal to 2. Whoops, sorry, 2x greater than or equal to 8. So x greater than or equal to 4. So our domain is from 4 to infinity. That's that. So you have a day to work tomorrow if you're a junior. If you're a senior, you don't have an assignment tomorrow. You guys are ready to move on to the next worksheet, which is composition, composition, composition. And you only have one more assignment after that. That will be on Monday. And your test is on what day? Thursday. So if you're part of the CNA class, I know that you're gone. Is he part of the CNA class? All right. Yeah. All right. Should we call him and check on him?
Yeah, that's cool.
We miss Braden, or we miss Brecken too.